Okay, so we're going to look at Lisp, and I've already given you a tour of Lisp, and you've started on your implementation, so you understand Lisp to some degree there. And if we were to just look at programming in Lisp, that introduction I gave was probably enough for you to go to the Common Lisp manual and go and understand how Lisp works. Okay. So what's going to be different in what I'm going to talk about is that I'm going to actually talk about implementation. Okay, so that's your function expressions. We're moving on now beyond function expressions. Okay, so we have to motivate what we're going to do next somehow. And let's go and use this particular example to motivate. Okay, so this is the example that we saw earlier. And let's go and see what we're doing really here. What we're really doing here, we don't know what these functions do quite, but we can look at mechanically, is create a new function, return a new function in which is free variables above. Right? That's all we're doing with this outer lambda. Outer lambda's job is to go and create a value for the free variable x, right? So we are creating this lambda expression, and x happens to be a free variable, and what we are doing is giving this free variable a value. To give this free variable a value, we create a lambda, and then we apply the lambda. Okay, you guys get that part? So that's essentially what we've done. This outer lambda is doing nothing else. It's not doing any computation. All it is doing is statically provide a value for the free variable in this lambda expression. Okay? Which involves creating a new function and applying it. Now, how would you do something like this in Java? Supposing you could return functions, and the function has a free variable. What might you do to go and statically bind the free variable to something in the defining environment? Yeah.
Because if you have a variable assigned to that thing in Java, it just doesn't let you compile.
No. So I'm saying, what might you? Okay. I've defined a function that is a free variable. That function can be put in any piece of code. The code in which it is being put is the defining code, right? And we're going to call that function sometime later. And I'm saying, how would you do it in Java? How would you go and statically give the free variable a value in Java? Supposing you could return functions. You could give it through the global scope. Okay, but then if you do it through the really global scope, to the class scope, it doesn't matter whether it doesn't matter as much whether you're doing static or dynamic. Okay? Dynamic might override the static, but the static value will always be available. Okay, if dynamic hasn't overridden it. So what do you do in Java? How can you have nested, another way to say this is, how do you get nested scopes in Java? Static scopes. Inner classes, that's one way. Other ways? Okay, so if you have a function within a class, that defines a scope, right? As it turns out, in Java and C, you can't have functions within functions. In Pascal, you could, yeah. Loops are blocks that can have variables. Can you have blocks without loops that have variables? Can you just put two curly braces and go and define some variables in them? Anytime you have two curly braces, you have potential new scope. We didn't have to go and define a function and call it to create an enclosing block that is not global. We could just go and put the function definition within an outer block. So now try to imagine what might you do in Lisp to mirror that functionality. I don't want to call a lambda, define a lambda and call it to go and give the variable a value. I just want to do something like a block. A lambda is a block, but a lambda is more than a block. Lambda is a function block, a function with parameters that can be called later. So, anybody want to invent some syntax? So I still want the lambda y plus xy. I still want the function around it because I want a function. I don't want to do a lambda x and then go and do application of that lambda x. I want to do something more efficient in terms of typing. Yeah. Lambda, good. Lambda, parentheses, x2 maybe, right? But then, we don't want to use keyword lambda because no longer a lambda. So we might go and use a certain term. And what English term might you want to dream of? What are we saying? We are really doing a set of some kind, right? So we'll just, but from ML, so all this outer lambda does is create a new scope in which free x is bound, 2 steps. We do the outer lambda definition, nested in lambda application. So what we'd like to do is just create a new scope, okay, just as a Java block, and bind free variables directly in one step, a Java-like block construct. So I'll do something like this. Rather than saying set, which might, because set is used for something else also, there's set q, c set q, I mean, there are all these nasty things in Lisp that were anti-functional programming. And we'll just say let. And let is going to be a list of variables and their initialization. So this happens to have only one variable in it. So we've said let x be true, okay? And we don't have to go and first create the lambda, then apply it. We just say let x2, define the function in it. Let expression goes and returns this function that we can apply later with the x bound to the x and the let. Okay? So we've got, again, the plus being a free variable, and the let is the one that's enclosing scope. And so that's the structure. And let's go and look at the structure. In general, we've got let, a let call, just like a function call. And we've got a list of variables being initialized. Okay, so we've got within parentheses a bunch of initializations, v1, e1, v2, e2, and so forth. And then we've got, just like a lambda, some optional expressions, and then a required expression. And we got the variable initialized. This is just like your good old Java block. This is much more natural from what you've seen, and optional expressions and so forth. Yeah.
Are the variable initializations required? Does it have to have a...
Yeah. So variables always have to be initialized because whenever you go and evaluate a variable, it's got to have a value.
Right, but like if I had let of no variables and then I just did it for that, would that work?
I wondered about that, and I didn't bother to sort of look at it because why would you do it?
Yeah.
But whether it's an error or not is a good question. We should certainly be slapped a little bit and saying why you're doing the stupid let. But I think you can make your program work. It's easy to make a program work. You just go through the list and initialize everything there is, and if there is no variable, so it's easier to not catch that error than to catch that error if it is an error. So I was going to look at it, but I just didn't. Okay. Okay, so let's go and look at how let is implemented. We know how to implement the more complicated thing. So I had half a mind to go and just say, go figure it out yourself. After all, it is extra credit in your assignment to do this let. So Andrew and I debated a lot before deciding to put let in the assignment. So again, when I learned Lisp, there was no let. So I'm biased by my learning. And let is in other languages like ML. So again, to be inclusive, to sort of give you a flavor of what happens in other languages, I figured it would be a good idea. And there are some neat applications of let that Andrew came up with. So, but the reason I wasn't so keen about it was not because I hadn't learned it, because if you've learned Lambda and Lambda application, we understand scoping pretty well. And so, what are we really understanding? But, every little thing we do, we understand a little bit more. So maybe I'm wrong. So that's why it's extra credit. It's sort of, it's optional. Okay. And let's look at Lambda versus let implementation. So the Lambda implementation is more complicated. Okay. You have to worry about 3 or 4 things. So you have to worry about the Lambda evaluator, which returns a Lambda expression. Okay, we have to worry about whether that expression happens to be atom or not an atom, and it's unintuitive to have it not an atom, to have it atom, and yet it is an atom because it's unintuitive to have a card encoder to it. So we had to worry about that. We had to worry about applying that Lambda expression to arguments. Okay, which means we have to create a new scope, bind formals to actuals, and we have to then in turn we have to go and create the new scope associated with values, and then we have to also go and evaluate the Lambda later with that in that new scope. So 3 things we have to do. Okay. In the case of let, do we need to create some object that we determine whether it's atomic or not atomic? With lambdas, we had to create a Lambda expression. That was a first-class entity in its own right, that we had to decide, about its nature. We had to decide if it's an atom or not. Do we have to create a let expression that is a new kind of expression? No, because so we do it all in one step. The let expression returns the value of the required expression. The Lambda expression returns the Lambda object, which can then be applied to arguments. That's why it was a multi-step process. This is a one-step process. Okay? So we don't have to do something like that. Do we have to create a new scope? No. If you don't create a new scope, why did we do a let? Right? Why do we put curly braces? To create a new scope. Right? So we still have to go and create a new scope. And we created the scope and evaluated things in 2 steps because the Lambda object was separate. But now we can just make the let evaluator evaluate everything together. So some steps were done by Andrew, some steps were done by you. Now you have to do all of these steps yourself, the ones that are relevant. Okay? So you get the idea? So we have this Lambda evaluator where we said Lambda factory, new instance, parameters and body. We just kept that around because we needed a let expression, a Lambda expression. Okay, which could be used much later. You define the Lambda expression at this point, you use it much later, so you have to go and store that somewhere. No equivalent in let. Okay, I'm just rephrasing what I said earlier. We don't have to have an equivalent of that. So this we don't have to do this one. We don't have to look at this code at all. We had this Lambda application helper, which actually went and created the new scope and put values in that. This is the thing that we still have to do. Okay, let needs to also create and store new scope. Then there was this thing that Andrew provided, where you could say lambda.eval in an environment, and it went through all the required expressions, evaluated them, then it returned all the optional expressions, evaluated them, and then it returned the required expression. This step was done by Andrew. Now we have to do it. Okay? So let needs to also evaluate optional required expression, returning required expression evaluated. Okay? So this is a point that Andrew kept making, that once they've got let, this is easy. Okay, so let's go and do. So let evaluator, now that I've given you all this background on how it changes, let's go and see whether we can figure any or all steps on our own. So we are given this structure. Okay, it begins with a let, and then we have the declared part as a list, and then the body as a lambda. So tell me what all steps we have to do at this point with given the structure. Not in this particular order, but just go and tell me what all steps we have to do here. Evaluate the expressions. Okay, that's something we have to do. Store it. Before we store it, what do we have to do? Sorry? New child environment. Okay, so I think we've got all the steps. So evaluate the body and exactly. Okay, so once we've got the environment, then evaluate all the optional and then the required. Okay, so yeah, that was a step. So we create the new child. We store the values. Okay, and after evaluating them, okay, then evaluate each of these guys till we reach the last optional, and then we return the required. Okay, again, I haven't implemented this stuff. Okay, this is just, I feel a little insecure talking about things I haven't implemented. So please, if this is wrong, tell me later if it's wrong or not. That's why part of the reason I ask you guys questions is to sort of correct myself too. Okay. And just so that we know what we are doing, or I know what I'm doing. Okay. We have to, let's go and see how this particular function call is evaluated. We evaluate the arguments, as we said before. We set the variable to 2 in the new scope in the environment. So we, on top of the global scope, which is empty, I create a new environment. I associate that with 2. And now I go and, now I process the, yeah.
Just evaluating the body arguments, like a function with the let child environment, right?
Yeah, so the body of the let happens to be returning a lambda. That's where lets are most interesting. Okay, so now I'm going to the body, which is going to return this function. So for that, I have to go and calculate a lambda, right? So I do the new lambda, just as I did before. I'm just evaluating the, yeah, exactly. Okay. But after this, I've got to create a new function, and that function gets the let environment, just as it got the lambda environment earlier. Okay. So the steps after this just follow. The only difference was that I just did it all in one step, and so the let evaluation. Okay, so after this is just going to follow what we saw earlier. Okay.